Hello once again. A new lesson in math. Today our goal is to identify transformations. This is the last lesson in our series of transformations and all of these things that we've talked about. We'll do a little review today in the middle of our lesson, and we're going to learn some new stuff. We're going to learn about transformations. There are rules for moving every point in a figure to a new location. So we're going to talk about some of those rules and ways to recognize them and identify the types of transformations. The first one I want to talk about is called translation. And as you can see, I have the SL underlined for the word, and think of the word slide. A transformation that moves each point in the figure the same distance in the same direction. So it basically slides to its new location. So what we're talking about, I'll give you some more information. It can slide up, down, left, or right, but there's no change in the shape or the size. The only thing that changes about it is its location. So when we're doing it on a graph, you're actually going to add the same number or subtract the same number to all the x and y coordinates. And let me show you on our graph. We're going to move that triangle, and you can see there it says, oh, I'm sorry, not necessarily always the same, all the same numbers, but in this case we want to translate it 4 to the right and 3 up. Okay, so watch how this works. You can really pretty much, using the same exact size shape, move any of these points, choose any point, and move it. And I'm going to go with the 4 right first. Okay, so I'm going to go 4 right. As you can see, we're on the origin, we're on the y-axis, and we're going to move 4 to the right. So just slide it on over there. See, slide. Now the next instruction says 3 up. So from there, we want to go up. Okay, up 3. And I'm using the same corner. It really didn't matter which corner. We would have ended up in the same place. And now we slide it on up. And there we are. Notice I didn't go too far up. Okay, I only went this far up. And I know it's a little crooked. That's just because I'm not real good at doing this. But it should be like right on that thing. But somehow I don't know how I got it crooked. It should look very much like this one. So just sliding is all we had to do. Now, the next one I want to talk about is the review one I was saying. Right in the middle of everything is our review. Reflection. We've already done it. And when you think of a reflection, think of flipping, okay, and the mirror image. Okay, so transformation of a reflection, using reflection, is where a figure is flipped across a line. Quite often it can be the x-axis or the y-axis. So we actually have a line, like right now, I think, well, yeah, you can't really see it, but you probably can't see it real well, but you can see my face is cut by the edge of our slide here, okay? I don't know. It shows up more from me, I think, than you. But you can see it from the bottom, where it's going to be. So the flip, if my hair was perfectly the same on both sides, I would be a reflection on both sides. So reflection is a mirror image of a figure, okay? It's formed across a line we call symmetry, which again, like I said, we talked about in the last lesson. There is no change in size, okay? The orientation of the shape changes, so it flips. Think of putting up a mirror right in the center of something, okay? So when we're graphing it, it's interesting that when we go across using the x-axis as our symmetry line, it changes the sign of the y. And across the y-axis, if we have that as our line of symmetry, it changes the sign of the x. Ooh, interesting, huh? Let's take a look at this on a graph. So here's our little shape. And it says here, reflection across the y-axis. So where's the y-axis? That's right here, okay? Right here. So we want to have a reflection of this over here. So think about it now, which direction will the point part go? Is it going to stay pointing off to the right? Or will it change and point up top? Or will it point down? Or will it point left? Take a guess. See if you can figure it out. Nope, it'll actually point to the left. And notice how it's flipped over. And also, if you notice, remember I said on the last slide that all the x coordinates change sign, and none of the y ones do. The y's stay the same. So if you think about it, look at this. The y coordinates are all, right, these two are all 2. Down here, they're all 4 on all of them. But this was an x coordinate of +1. This is an x coordinate of -1. See how that worked? So if you can have the rules handy, and I will put them on a sheet, you'll be able to answer those questions. All right, rotation. To rotate means to turn. And in this case, it's a figure that turns around a fixed point. Now, our last one, it was a fixed line, a line where we did the reflection. Now it's just a point. All right, we're going to rotate around a fixed point, like right here, okay, without changing its size and shape. So let's hear about those rules. Oh, I covered up some of it. Sorry, guys. In a rotation, a fixture turns around a fixed point, such as the origin. Quite often, the origin is used. There is no change in shape, but the orientation and the location change. So, if we're going to change it around the origin, okay, and it's going to be a 90-degree turn, that's 1/4 of the way around, we're going to switch the coordination of each point and then change the sign of the y. Whoa. So if a point happened to be at 2, 1, it's going to become 1, -2. Ooh. I wonder how the 180-degree one would turn. That's halfway around, right? Coordinate points stay the same, but become opposite signs. Oh, look at that. So at 2, 1, it just changes to -2, -1. Interesting, isn't it? Let's take a look at an example. This says to rotate it 90 degrees. Now I'm going to pause here, and I want you to think about this. Right now it's in quadrant 1. If we're going to rotate it clockwise about the origin, which is right here, this is going to be our center of our rotation, and we're going to go clockwise, what quadrant would this triangle end up in when we do our 90-degree rotation, okay, around the origin? Answer that for me right now. Okay, now that you've answered it, let's see if you're right. You ready? Here we go. I hope you said quadrant 4 because that's exactly where it went. If you change all of these were all positive points. If you change them all to negatives, this is where we end up. Isn't that interesting how it... And if I could have created an animation and put my point here and taken this whole thing and turned it around, all right, and just turned it around clockwise, 1/4 turn, I would have gone from here to here. Pretty cool. I hope you can imagine that in your head. I know that's harder for some, but it's real easy for some others. Well, guys, that's it. That's identifying transformations. I will have a help sheet with all the rules on it for you, and that should help keep it all straight. Okay? Well, thanks for watching. Have a wonderful day.